Okay, so from what we explained earlier, that for a projectile that starts from the point of projection, that is from the origin, and then travel all the way to the highest point before returning to the ground, there are two components of the velocity, the vertical and the horizontal. Since the vertical is dependent on acceleration due to gravity, and this object, when going up, is going against gravity. So the value of that velocity, the vertical velocity, will be decreasing by a value of 9.8 for every 1 second as this thing goes up. When we show the animation, you see that the vertical arrow was reducing in size when this object is going up. But when it is coming down, the vertical arrow was increasing in size. Okay, we can calculate the value of this vertical velocity any instance of time using the equation of motion v equal to u plus or minus gt. Now, it is plus when the object is coming down, it is minus when the object is going up. So, since we are concerned about the vertical component of the velocity, then the velocity of projection is projected at an angle theta to the horizontal. Then we resolve it to the vertical and the horizontal component. That's the essence of resolving it there. Then the vertical component we say is u sine theta, while the horizontal component is u cos theta. So here we are calculating the value of the vertical velocity. So the initial velocity in respect to that is u sine theta, not u cos theta, because the velocity along the vertical axis at any instant of time, the initial is u sine theta. So using this u now is equal to u sine theta as our initial velocity. Yg is a constant. Then in that case, the vertical velocity is u sine theta minus gt when the object is going up, or when it is coming down, the vertical velocity is u sine theta plus gt. Also, we can calculate the vertical distance of this object at any instance of time. So the object is going up until it attains a maximum height at this point. And then once maximum height is attained, there is no more vertical component of velocity. It's zero. Because of that, the object begins to come down again. So we can calculate the distance along the vertical axis using the equation of motion s equal to ut plus or minus half gt squared. Again, u is u sine theta, so that the distance s is u sine theta times t minus half gt squared when the object is going up. And when the object is coming down, s is u sine theta times t plus half gt squared. The question is, do you need to cram this formula? No. What you need to remember is the equation of motion. And you also remember that when something is going up, because it's going against gravity, g is negative. But when it is coming down, it's going in the direction of gravity, g is positive. Now we are using u sine theta here because we are talking about the vertical distance. The velocity that is making it to go along the vertical distance is the vertical component of the velocity, which we found to be u sine theta. So with this information, we can calculate or derive formula for time to reach maximum height, time of flight, and the range of a projectile. Let me quickly clean the board so that I have a space to breathe. Okay, so time to reach maximum height, time to reach maximum height, which is represented with small letter t. We said earlier that the velocity of this object at any instant of time as it is going up is given by v equal to u plus or minus gt. So in this case, we are talking about time to reach maximum height, time to reach maximum height. So once the object is at maximum height, the final velocity v is zero, which we learned from our previous class. And I've mentioned that separately. I will show an animation. When this object was going up at maximum height, the vertical arrow becomes zero completely. That is to tell you that velocity at maximum height is zero. Then initial velocity is u sine theta, which is the vertical component of the velocity. But that is what is driving this thing upward. U sine theta. Maximum height, this thing is going up, so g is negative. It's going against gravity. So we use negative g. And we are looking for t. So if we substitute all of this into this equation, 0 is equal to u sine theta minus gt. So that if I move this u sine theta across the equality, it becomes minus the 0 minus u sine theta is equal to negative gt. 0 minus u sine theta is negative u sine theta equal to negative gt. The negative we cancel out. We are looking for t, so we divide both sides by g. T therefore u sine theta over g. So this is called time to reach maximum height. The formula is t, small letter t, equal to u sine theta over g. I mentioned earlier that the time taken for this projectile to reach maximum height is the same as the time taken to fall from maximum height to the ground. So if time taken to reach maximum height is small letter t, is the same t that it will take to fall from that maximum height to the ground. For example, let's say the time is 2 seconds, it's the same 2 seconds it's going to take to fall to the ground. So as such, the time of flight, which is capital T, is 2 times the time to reach maximum height. That is T equal to 2 u sine theta over g. Now we can prove that with equation of motion. We said that the distance of this projectile along the vertical axis as it goes up is obtained by the equation of motion s equal to ut. Since the object is going up, that will be minus half gt squared. Now, this object travel all the way to the maximum height and then fall to the ground. I'm talking about time of flight now. So now it's on the ground now. So what is the distance along vertical axis? Zero, of course, because it starts from here, move to the maximum point, and then return to the ground. So distance along vertical axis is zero. Then initial velocity of projection is the vertical component of the velocity. But that is what makes it to go up before coming down. So that is u sine theta. Okay, so u sine theta times t times t. Now the t in this case will be capital T since it's time of flight we are talking about, not time to reach maximum height. So we're using a distance of 0 to show that the projectile is now on the floor from where it started from now all the way to this point. So u sine theta times capital T, this small letter t, now turn it to capital letter T, minus half g, the same thing, I will turn this to capital letter T. Now solving for capital letter T, u sine theta times T is ut sine theta minus half gt squared. If I move this u sine theta, ut sine theta rather, across the equality become minus. So 0 minus ut sine theta is equal to negative half gt squared. And we know that if I have half a, I can write that as a over 2. So 0 minus ut sine theta is negative ut sine theta equal to negative gt squared over 2, applying what I said here. So instead of having it as half, so that you can see clearly what I want to do, the minus will cancel out. So I have ut sine theta equal to gt squared over 2. This one is over 1. So when we cross multiply, gt squared times 1 is gt squared equal to 2 times ut sine theta is 2 ut sine theta. T cancel here, then one of the t will cancel here. But t squared means t times t. So I cancel 1, it remains 1 then. So that gt equal to 2u sine theta. Dividing both sides, since we are looking for t, time of flight, dividing both sides by g, time of flight, is 2u sine theta over g. Do they agree each other or not? The same thing. So 2u sine theta over g, 2u sine theta over g. So that is the time of flight. So recall that the time of flight is the total time taken for the projectile to move from the point of projection to the point where it hits the ground again. While time to reach maximum height is the time taken for the projectile to move from the point of projection to the maximum height attained. That one is represented with small letter t, while time of flight is represented with capital letter. There are two different things. The small letter t is u sine theta over g. Capital letter T is 2u sine theta over g. Then maximum height attained. How do we derive a formula for that? We can derive the formula by making S the subject of the equation. Using the equation S equal to ut minus half gt squared. But we're talking about maximum height. The thing is going up. That's why it has to be minus here because g is negative. So in this case, our initial velocity u is u sine theta is u sine theta, while the time t is the time to reach maximum height, which is u sine theta over g. So substituting this into this equation, S will be u sine theta times u sine theta over g minus half times g times t again is u sine theta over g, the u sine theta over g squared because the t is squared there, squared. Now u sine theta times u sine theta, that is this one times this, u times u is u squared, then sine theta times sine theta is sine squared theta over g minus half g times u sine theta squared is u squared sine squared theta over g squared. Because this square affects both the numerator and the denominator. U square is u square, sine theta square is sine square theta. So this g square means g times g. So that one of the g here will cancel this g outside. As such, I will have s, this s then, this one, equal to u square sine square theta over g minus 1 times u square sine square theta is u square sine square theta. Then 2 times g is 2g. LCM of g and 2g is 2g itself. 2g divided by g is 2 because the g will cancel. Then 2 times u square sine square theta is 2 u square sine square theta. Then 2g divided by itself 1. 1 times u square sine square theta is u square sine square theta over 2g. So s is equal to that. 2u square sine square theta minus 1u square sine square theta. 2 minus 1 is of course 1. Therefore, 2u square sine square theta minus 1u square sine square theta is 1u square sine square theta n over 2g over 2g. This is the maximum height attained by the projectile u square sine square theta over 2g. And you can replace this s with h mass if you like, but you will see that in some textbook. H mass because of course the maximum height, we are talking about height, the h there represent height. So h mass is u square sine square theta over 2g. That is the maximum height attained by the projectile. The next thing is the horizontal distance traveled by the projectile, and the horizontal distance, which we call range of the projectile, is the distance traveled from the point of projection to the point where the projectile will return to the ground. The distance along the horizontal axis from the point of projection to the point where the projectile lands on the ground. That is the range of the projectile. Now that range, which is the horizontal distance, is dependent on the horizontal component of the velocity. It doesn't depend on the vertical component of the velocity. Also, it doesn't depend on acceleration due to gravity. When something moves in a parabolic manner, the horizontal motion is independent of gravity. It's only the vertical component that is affected by the gravity. So as such, using the same equation that gave us maximum height, S equal to ut plus or minus. I'm going to use plus here since it's independent of gravity. It's gravity that makes it to be either plus or minus. Minus when the object is going up, then plus when it is coming down. But since here it is independent of gravity, let's use plus half gt squared. But g is 0 since the horizontal component is independent of gravity. Also, our initial velocity here is u cos theta. That is the horizontal component of the velocity, u cos theta. Then the time t is the time of flight, not time to reach maximum height. Because range, the body is now on the floor. We travel all the way to the maximum height before coming down to this point where it is right now. Is this distance along the horizontal axis that we are talking about? So is the time of flight all the way down to this point. So t is equal to the time of flight, capital T, which is 2u sine theta over g. So if we substitute that into this equation, that is equal to u cos theta times 2u sine theta over g, which is u times 2u is 2u squared. Then cos theta times sine theta is cos theta sine theta over g. Now, this I can write as, I want to bring out this u squared, then times 2 cos theta sine theta over g. I did this because in further mathematics, there is something we call double and triple angle formula. Now, this one is coming from double angle formula. Now, what does double angle formula say? We say that sine A plus A, let me start with sine 2A. Sine 2A, which I can write as 2A, I can write it as A plus A, right? Equal to sine A plus A. And the double angle formula says that sine A plus A is equal to sine A cos A plus cos A sine A. Now let me use different letter so that I'll drive my point home. Let's assume we have sine A plus B. The formula is telling us that you take the sine of A, multiply it by the cosine of B, then add the result to the cosine of A multiplied by the sine of B. That is double angle formula. So where we have it as the same letter here, A and A, sine A cos A plus cos A sine A. Now this first value is the same thing as the second value because multiplication is commutative. Now what does that mean? It says something is commutative, an operation is commutative when if you reverse the order of operation, the answer is still the same. For example, 2 times 3 is the same thing as 3 times 2, yes or no? The first one, 2, come before 3. That is 2 is multiplying 3. The second one, 3 is multiplying 2. So I reverse the order of operation. But for both of them, the answer is 6. So such an operation is said to be commutative. So the operation of multiplication is commutative. As such, this sine A times cos A can be added to cos A times sine A. So that when we add them, we can write that as 2 sine A cos A. That is like adding 1 plus 1. So in this are the same. Sine A cos A plus cos A sine A. We added the two together since the operation of multiplication is commutative. This first operation is the same thing as the second operation, irrespective of the order of operation. So if that is the case, now let's compare this with what we have here. This is 2 cos theta sine theta. So let's assume it is theta. Instead of having A here, instead of having A here, it's as if I have sine 2 theta, which I can split to sine theta plus theta. Then according to the double angle formula, that is sine theta cos theta plus cos theta sine theta. Since multiplication is commutative, we can add the two. We have 2 cos theta sine theta. Exactly what we have in our formula here. The question then is, what gave rise to this? It is sine 2 theta that gave rise to that. So because of that, we can replace this expression inside bracket with sine 2 theta so that s becomes u squared sine 2 theta over g, which is the range of the projectile. So since the distance s here represent the range of the projectile, I can turn the s to r equal to u squared sine 2 theta over g. That is the range of our projectile.